Hi all, welcome back to the channel and to the numbers to decisions. In today's session, we are going to talk about a transportation problem. So the method what we are going to discuss is Vogel's approximation method. So compared to the other methods, northwest corner rule and least cost method, Vogel's approximation method which gives you a most optimized answer. So that means you will get much more minimized cost in terms of transportation. So otherwise, they call this Vogel's approximation method as FAM also. So we are going to go with the same example that we discussed for the previous two methods. So today we are going to do with your VAM method. So here again, first thing is you have to check whether the problem is balanced or not. So already we have done the balanced one. So 34 for the demand and 34 for the supply. The problem is balanced. So once after checking whether the problem is balanced, we can proceed with VAM method. So VAM method is quite different from the other two methods. So first what we need to do is first in the first row, okay. So that is origin 1, okay. So we have to choose the least value. So which is the least value that we need to select first, that is 2, and we have to subtract with the next least value. So the next least value is 4, okay. So first we need to select the least and next we need to subtract that with the next least value, okay. So here 2 is the least and 4 is the next least, so we have to subtract these two values. So the difference is 2, okay. And the next one is the next row, same thing we have to repeat. So one is the least and the next least is 3, so the difference is 2 again. And the next row we have to look at, the least value is 4 and the next least is 5, so the difference is 1, okay. And the next one is row number 4, that is origin 4, the least is 1 and the next least is 2, so the difference here is 1 again. The same that we have to do it with the column also. So in this column the least is 1 and the second least is 2, so the difference is 1, and the second column the least is 3 and the next least is 4, the difference is 1, and here again the same, 1 is the least and the next least is 2, so the difference is 1, okay. So in this, the next decision is you have to choose which is the highest difference, okay. So you have 2 3 2 1 and everything is 1, so you have to choose the highest difference, either it can be row or it can be from the column, okay. So the highest difference is 2, we are getting at 2 places, okay. So when this is there, arbitrarily you can choose any one, okay. So in this case I am going with the first two, okay. So this one I'm going with, okay. So let us do the allocation, okay. So after finding the highest difference, you have to start doing your allocation. So here how we are going to do the allocation is, you're going to do the allocation in this particular row, okay. So in this particular row you need to find out the least value. So the least value is 2, okay. So there only we are going to do the allocation. So what is the demand? The demand is 7 and the supply is 5. So how much we are going to allocate here is, we are going to allocate 5. Enter, supply gets over, so I am going to cross out the entire row. So now the demand rests with 2, okay. So now again I have to repeat the same step, okay. So first row I don't have any elements, so I need not to find any difference. So the next the elements, I need to choose the least and the next least the difference, okay. So 1 and 3, so the difference is 2. Here again 4 and 5, the difference is 1. Here again 1 and 2, the difference is 1. So now between 1 and 3, the difference is 1, and here 3 and 4, the difference, sorry. So here the difference is going to be between 1 and 3, the difference is 2, So here between 3 and 4 the difference is 1. Here 1 and 2 the difference is 1. Okay. So now among these we need to find out which is the highest difference. So here again we are getting it 2 points. One is here, the other one is here. So here again arbitrarily you can choose any. Okay. So I am just going to take this 2. Okay, so in that particular row only we are going to make the allocation. So in that particular row the least value is 1. Okay, so this is the least value, so here only we are going to do the allocation. So let us look at what is the demand. The demand is 18 and the supply is 8. So how much we can allocate? We can allocate 8 here. The entire supply gets over, so cross out the entire values, and that demand remains as 10. Okay, so again we have to repeat the same step. So first row we don't have elements, second row we don't have elements, third row we have elements. So the least is 4 and the next least is 5, so difference is 1. Same repeats here. So here 1 is the least and the next least is 5, so the difference is 4. And here the least is 4 and the next least is 6, so the difference is 2. So here the least is 2 and the next least is 7, so the difference is 5. Okay, so here when you look at the highest difference is 5. Okay, so we need to start allocating from 5 only. Okay, so in that column only we have to make the allocation. This column only we have to make the allocation. So already 4 and 1 is ruled out. We have only 7 and 2 where we can do the allocation. So as per Vogel's approximation method, we have to go with the least value. Okay, so the least value is 2. So the demand is 10 and the supply is 14. So we have to allocate only 10 here. Okay, so 10 we are allocating, the entire demand gets over, so cross of the column values, and the supply remains as, sorry, it is going to be 4. So and the supply remains as 4. Okay, so now again we have to repeat the same step. So this column we don't have elements, and first row, second row we don't have elements. Okay, so now 4 and 5 the difference is 1. 1 and 6, the least is 1 and the next least is 6, so the difference is 5. And the next column, the first column, we have 1 and 5, the difference is going to be 4, and this is the next, so the difference is going to be 2. Okay, so now the highest difference is 5. So 5 is representing origin 4, so we have to allocate in origin 4. Okay, so in this the least value is 1, so here only we are going to allocate. So the demand is 2 and the supply is 4, so you can allocate only 2 here. So the supply remains as 2, and as the demand gets over, so you have to cross out the other values in the column. Okay, so now we left out with two values. Okay, so among these two values you have to find out the next least value. Okay, so the least value is 4. Okay, so here you can make the allocation. So what is the demand? So demand is 9 and supply is 7, so only we can allocate 7 here. The entire demand gets over and you have the supply of, sorry, entire supply gets over, you have the demand of 2. So and the final value is 6 where we can allocate 2. So the entire demand and supply gets over here. Okay, so this is how we have to do with your WAM method. Okay, so here again you have to check whether the solution is non-degenerated or not. So how we will check? M plus n minus 1, which should be equals to number of allocation. Okay, so first let us see what is m plus n minus 1. M is 4 plus n is 3 minus 1, which is equals to 6. And let us count how many allocations we have. So we have 1, 2, 3, 4, 5 and 6. So we have totally 6 allocations. So therefore the solution is non-degenerated. Okay, so now we need to find out what is the total transportation cost. Okay, so here what we need to do, number of allocations multiplied with the cost. So 5 into 2 plus 1 into 8 plus 7 into 4 plus 1 into 2 plus 6 into 2 plus 2 into 10. So the total transportation cost is 80. Okay, as I told you, compared to the other two methods, WAM and the northwest corner rule and the least cost method, WAM is a better optimization method, because northwest corner we got 102 and least cost method we got 83. Okay, so now WAM is better compared to your other two methods. Okay, so this is how we are going to do with your Vogel's approximation method. And thank you for watching the session. We'll meet with another video in the next session. See you until then. Bye from Santosh.